Well, hello one and all, and welcome to our short on string methods. I have here a list of strings representing titles of shows for children in the 90s or so. So you might notice that a few of these show titles aren't really appropriately styled. I have some spaces at the beginning, even at the end. I have some mixed capitalization. These are all common mistakes you might get when you work with data, particularly user-entered data. So let's see how we could clean up a little bit these titles of shows. I have down below a main function that a little bit these titles of shows. I have down below a main function that iterates over every show in this list of shows, currently just printing it out to my terminal. So I'll go ahead and run python of shows.py, and I'll see all of these show names down below in my terminal. But my goal is to clean these up a little bit. I want to make sure they have the appropriate capitalization, that we're removing extra spaces. So this is a great job for string methods. Again, methods here refer to functions that belong to some kind of object, in this case, in particular, a string. So if I have a string, I can use a variety of methods to clean it up, or these functions that belong to strings. Now, one I want to show you is one called capitalize. And I can take each string here, referred to as show, and capitalize it when I print it out. I could do show dot capitalize using this method by using dot notation here, taking my string, the name of it at least, dot, and then the method name, capitalize. Here, if I run python of shows.py, let's see what we get. I get certainly a capital letter at the beginning, except for those with spaces, but I don't think I've achieved my goal of making sure all of these strings are appropriately titled. So it turns out capitalize, this method, actually only uppercases the first character in your string. In this case, I had a space, and you can't really uppercase a space, but I don't think this is exactly what I want. Now, thankfully, there actually is another string method, one called title, which will title case my strings for me. So if I run python of shows.py, let's see what happens. Now I think I'm approaching the capitalization I wanted. I see every word, in this case, capitalized in each of my strings. In other words, these are title cased, where we assume you're capitalizing every word in the title of something. So I'm approaching a better, a more clean version of these show titles, but I still want to get rid of these spaces on either end of our shows. So thankfully, I can use a function you may have already seen, one called strip. And it is a function, but it's more specifically a method attached to this string called show. So I'll go ahead and do python of shows.py, and we'll see that now I've stripped off those spaces, but I don't have the appropriate titling anymore. So thankfully, I can actually chain string methods together. If I want to not just strip my show titles of their leading and trailing spaces, but also put them in title case, I can actually do just that. I could do something like this, show.strip, and then title. What this will do is take my show string, first strip the leading and trailing white space, and then convert the result to title case, capitalizing every word. I'll then run python of shows.py, and we'll see that I now have the best of both worlds thanks to this ability to chain our string methods together. So I think these are looking pretty good, but let's say I want to put them in a new list. I'll do just that here. I'll do cleaned shows is first an empty list, and I'll then append each new string to, in this case, my cleaned shows list. Now, if I go down below and print cleaned shows, I should see, fingers crossed, a new list of shows, in this case, ones that are appropriately title cased and also removed of their leading and trailing white space. But if I wanted to show the user this list of shows, this isn't really the best format to do it in. Here they see the Python list syntax. They see quotes around every string. So there actually is a way to pretty print, if you will, this list. I can take a string like this one, a space for instance, and I can use a particular string method that actually takes as input a list. I can do .join, and I can provide as input here to join cleaned shows. Let's try printing this result here and see what happens. I'll run python of shows.py, and now I see my shows in my list joined together, in this case by a space. Here I see Avatar, The Last Airbender, followed by a space, followed by Ben 10, followed by a space, and so on throughout the rest of my list. So join works by specifying first a string you want to use to join your list elements. Join then takes as an argument the list of, in this case, shows you want to join together. Now, let's actually change this to something like a comma. We could then have the name of the show, comma space, a new show, comma space, a new show, and so on. I'll go down below and run python of shows.py, and we'll see down below a list of these shows now better formatted with commas joining each of them together. So this was a brief look at string methods and what you can do with them. There are many, many more in the Python documentation, so be sure to read about all you have at your disposal. You've seen here, though, a few that help you clean up strings, ones like strip, ones like title, and ones like join too that can help you format your strings for printing to the user. This then was our short on string methods, and we'll see you next time. Well, hello one and all, and welcome to our short on side effects. So we've seen that functions are these things in programming languages that take inputs and produce outputs for us. Now we've seen really that there are various kinds of outputs. One of them is called a return value. The value the function gives back to us after it finishes running. But it turns out there's also a kind of output known as a side effect, which is not the return value, but anything else that gets changed while our function is running. So let's take a peek at an example here. Here I have a program called machine.py representing some machine with some internal emotional state. Notice how up at the top here, I have an emoticon representing our machine's emotions at this given point in time. In this case, it has this particular emoticon representing something like sadness or forlornness. And so we'll see if we can make our machine more happy as we write our program. But ideally, we want this machine to say something to us. And so let's go ahead and write ourselves a function called say that we can then call inside of our main function here. So I will, underneath main, go ahead and write for myself a function called say, using the Python keyword def and the name for the function, say, and maybe say should take as input, as an argument here, maybe something called phrase, the phrase to say. And so by convention, I will indent within this code block here to write the body of my function, the code I want to run when say is called or used in my program. Well, what should say do? I think really to say something, our machine should print something to the terminal. And so we can do that with a Python function known as print, just like this. And what should print? Print, well, probably the phrase in this case, the phrase we gave as input to say. Now, if we're just using print, we haven't really added much functionality here to the say function. So why don't we have the machine able to say something, but then maybe append the emoticon at the end, so it kind of says something with emotion here. I'll go ahead and say print the phrase, but then also print on a space followed by the emoticon itself up top here. So notice how phrase is really a local variable. It's passed as input to this function say and used within inside that function. Emoticon, though, as a global variable defined at the top of our file here, is able to be accessed by any particular function, in this case, say included. So ideally, say should then say whatever phrase we have, followed by a space, followed by the emoticon representing our machine's emotions. So why don't we try this out? In the main function, which will be run as we run our program here, I'll say, maybe, oh, is anyone there, question mark? And so if we run our machine down below, I'll say python of machine.py, hit enter, and we'll see, is anyone there, with a little bit of a sad face. So we made ourselves a sad machine, but let's go ahead and try to make it happier as we go through. So maybe it could later on say something like, oh, hi, just like that. And if I were to go ahead and run this, I'll say python of machine.py, hit enter, and we see now 2 lines of text. Is anyone there? And oh, hi. Now, there's some things to fix. Ideally, the emoticon would be happy in the terminal down below when it says, oh, hi. But before we go there, let's first take stock of what we've done. Like, we've actually written a program that has a side effect. This is one example of a side effect, printing to the terminal in this case. So our function, say, has the side effect of printing to the terminal. But what other kinds of side effects might there be? Well, we mentioned earlier that a side effect is really anything that gets changed while our function is running that is not the return value we actually give back at the end of our function. So maybe inside of main, we could try to change the emotional state of our machine as a side effect. So let's try this out here. I'll clear my terminal with Control L. And then I'll go on to line 6 here. And before we say, oh, hi, let's try maybe making the emotion a little happier in this case. I'll say colon D for the big smiley face. And ideally, if we were to run this program, we'd see, is anyone there, with a bit of a sad face, followed by, oh, hi, with a bit of a happy face. I'll run python of machine.py. We seem to still have ourselves a sad machine. So how can we improve this? Well, notice first here that emoticon, if you can see very slightly, is gray. Oh, your farm is running. There. Let's see when they down below. And run our program here. I'll say, maybe, oh, is anyone there? Question mark. And so if we run our machine down below, I'll say python of machine.py, hit enter, and we'll see, is anyone there, with a little bit of a sad face. So we made ourselves a sad machine, but let's go ahead and try to make it happier as we go through. So maybe it could later on say something like, oh, hit enter, and we see now 2 lines of text. Is anyone there? And oh, hi. Now, there's some things to fix. Ideally, the emoticon would be happy in the terminal down below when it says, oh, hi. But before we go there, let's first take stock of what we've done. Like, we've actually written a program that has a side effect. This is one example of a side effect, printing to the terminal in this case. So our function, say, has the side effect of printing to the terminal. But what other kinds of side effects might there be? Well, we mentioned earlier that a side effect is really anything that gets changed while our function is running that is not the return value we actually give back at the end of our function. So maybe inside of main, we could try to change the emotional state of our machine as a side effect. So let's try this out here. I'll clear my terminal with Control L. And then I'll go on to line 6 here. And before we say, oh, hi, let's try maybe making the emotion a little happier in this case. I'll say colon D for the big smiley face. And ideally, if we were to run this program, we'd see, is anyone there, with a bit of a sad face, followed by, oh, hi, with a bit of a happy face. I'll run Python of machine.py. We seem to still have ourselves a sad machine. So how can we improve this? Well, notice first here that emoticon, if you can see very slightly, is grayed out. And this is because Python, by default, wants us to specify that we're trying to change some global variable inside of a function, this more local scope. So our side effect that we want to have happen is to change this global variable, but because this isn't always desirable, Python wants us to explicitly specify what we're going to do. So to do this within the main function, what I can do is use this keyword called global. And I can specify after global the global variable I want to make accessible and modifiable within this particular function. And key thing there is it's now modifiable, not just accessible. Notice how in say, it was accessible to us, emoticon was, but in main, it wasn't modifiable. I couldn't update this variable. If I now say global emoticon, I'm able now to modify the actual value of that variable as a side effect. Not the return value here, but just a side effect as this function runs. So here again, we have our global emotional state for our machine. We then have our function called main. Within that function, we say we're going to be able to change this global emotional state that we called emoticon. We'll first say, is anyone there? Change the emotion, and then say, oh, hi. So let's try this out. I'll go ahead and run python machine.py, and there we go. We've now seen another version of a side effect, one that changes some global variable. Now, in programming, this may or may not be desirable. If you have a global variable that is accessed across many other functions, it can be hard to debug your code if that variable gets modified across all these different functions. So keep in mind, when you use side effects like these, make sure it's good design, the right decision to actually make when you're writing your program. But here we've seen two examples, printing to the terminal, modifying some global state. There are others too, but I'll leave that for a later time. We'll see you next time.
All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this week we focus on conditionals. Conditionals, or conditional statements, in Python and in other languages, are this ability to ask questions and answer those questions in order to decide, do you want to execute this line of code, or this line of code, or this other line of code instead? They allow you to take the proverbial forks in the road within your own code logically. So how might we go about making some of these decisions? Well, it turns out that Python comes with a lot of built-in syntax. For instance, here are just some of the symbols you can use in Python to ask questions. Admittedly, mathematical questions, but we'll start there if only to keep the example simple early on. This first symbol, as you might know from math, represents greater than. The second symbol might not look too familiar because we usually write it all as one thing on a piece of paper. But on a keyboard, if you want to say greater than or equal to, you'd use this symbol instead. This, of course, means less than. This means less than or equal to. And this one's a bit of a curiosity. We've seen in our look at functions and variables how we were able to assign values to variables using a single equal sign. But that equal sign didn't represent equality. It represented assignment from right to left. That's great because it solved that problem, but it kind of left us in a bit of a bind because how do we now compare two things left and right? Well, in Python and in many languages, you actually use two equal signs. So two equal signs represents equality, comparing the thing on the left and the right. One equal sign, as always, represents assignment, copying the thing from the right to the left. Lastly, this last symbol represents not equal to. So the exclamation point or bang followed by an equal sign means not equal to some value next to it. Well, to ask the questions using these symbols or any others, we're going to need another keyword in Python. And that keyword, quite simply, as in English, is if. You can ask questions in Python code along the lines of, if the answer to this question is true, then go ahead and execute this code for me. So let's go ahead and write some of these examples here. I'm going to go over to VS Code, and let's go ahead and create a program first called compare.py, the goal of which is simply to write code that compares values and makes decisions based on those values. Let's go ahead and type code of compare.py in order to create a brand new file called compare, in which we'll start to express some of this logic. All right, well, what do we want to compare? Suppose we want to compare, for the sake of discussion, just a couple of integers, but we'd like those integers to come from the user so that we can make decisions based on numbers we don't know the values of in advance. Well, let's go ahead and do this. As we've done in the past, let's declare a variable like x. Let's assign it equal to the return value of the int function, and pass to the int function the return value of the input function, asking the user a question like, what's x, question mark, as we've done in the past. Let's do this one more time with y, asking the user for the value of y, and again, converting that ultimately to an int as well. So at this moment in the story, we have two variables, x and y, each of which has values. And ideally, we should be able to now compare these values. So suppose I want to make a decision based on the values of these variables. I'm going to use the keyword if, and I'm going to use some of those mathematical symbols to actually ask the question itself. So how about this? If x is less than y, then let's go ahead and just print as much out. Quote unquote, x is less than y. So this isn't a very interesting program yet. I'm literally just stating the obvious based on the math, but it's allowing me to now introduce some new syntax. And exactly what is this syntax? Well, it's this. Not just the keyword if, which I've added here at the start of line 4, but then I ask my question here. X less than y. X is one variable on the left, y is one variable on the right, and of course the less than sign is expressing the mathematical question I have. What I've highlighted here is technically called a Boolean expression. A Boolean expression, named after a mathematician named Boole, is simply a question that has a yes or no answer, or technically a true or false answer. And that's nice because if there's only two possible answers, it's very easy for me, and in turn the computer, to make a decision. Do this or don't do this thing. Now notice, if you come from other languages, you might notice that I have not typed any parentheses. They are not, in fact, necessary, at least in this case in Python, but I have typed a colon at the end of the line. And even more importantly, at the next line, I have begun my line with some indentation, hitting the spacebar 4 times or just hitting tab once, which will automatically be converted to the same. That indentation is what tells Python that line 5 should only be executed if the answer to line 4's question is, in fact, true. So if x is less than y, that phrase will be printed thereafter. Well, let's add a few more lines of code. How about another question? If x is greater than y, then let's go ahead and print that. X is greater than y. And let's do one final question. If x equals y, then, wait a minute, what have I done wrong here, right? A good I here. I don't want to assign y to x. If x equals y is how I express equality. Let's go ahead and print out x is equal to y. So I now have 3 conditions, if you will. One question asking x less than y, one asking x greater than y, one asking x equals y. Let's run the code. Well, down here in my terminal window, I'm going to run Python of compare.py and hit enter. What's x? Let's go with 1. What's y? Let's go with 2. This should, of course, execute that first line of code and tell me, indeed, that x is less than y, exactly as I would expect there. Well, what just happened, though, in code? Well, let's take a look perhaps at this same code visually, particularly if you're a more visual learner. This, I dare say, is what just happened. So what we're looking at here is a flow chart. It's a diagram of this program's logic, and more technically, it shows the program's control flow. That is, the ability of you in code to control the flow of a program, generally from top to bottom. In fact, let me go ahead and zoom in on the top of this flow chart, and you'll see an oval at the very top that says quite literally start. That is, irrespective of what shape or layout the diagram is where your own thinking and logic should start when trying to wrap your mind around this program. Notice that there's an arrow from start to this diamond shape, and inside of that diamond is a question, a Boolean expression, x less than y. And this shape just means, based on the answer to that question, go left or go right. Specifically, go left if the answer is true, or go right if the answer is false. Well, the inputs I typed were 1 and 2 respectively for x and y. So of course, 1 is less than 2. So that's why my program printed out, quote unquote, x is less than y. But recall the code. The code then proceeded to ask 2 more questions. Is x greater than y? Is x equal to y? Well, the flowchart depicts those questions too. Notice that no matter whether the question had an answer of true or false, the arrows both converge back down to this second diamond shape here. And that second diamond shape asks the second question, x greater than y. That too has a true or false answer, so we go one way or the other. But if x is 1 and y is 2, then no, the answer is false. 1 is not greater than y. So logically, in the flowchart, you follow the false arrow this time. And notice, along that false arrow, you don't print anything this time. That's why we only saw 1 print out on the screen. Now, there was still a third question, and this flowchart captures that as well. The third diamond asks, x equals y. Now, that too has a false answer in this case, because 1, of course, does not equal y. And so we again follow the third false branch here. And that leads us, of course, to stop. And stop just indicates that's it for the program. So I think that's correct. And that particular flowchart does happen to represent the actual code that I wrote. So it's correct. It does what it's supposed to do. It answered the question correctly by printing on the screen x less than y. But what is perhaps poorly designed about it? Let's make this first distinction. It's not enough necessarily for the code that you write to be correct and do what you intend. Longer term, especially as our programs get longer and more sophisticated, more complicated, we're going to want them to be well designed too. Thoughts on in what way this program is arguably not well designed, even though it's correct? Let's see here. Khalid, if I'm saying that right, your thoughts?
Too many ifs, I think, is getting repetitive. We can make our code more concise, maybe.
Yeah, it seems a little repetitive. I'm asking if this, if this, if this, and yet logically, I should know the answer to some of those later questions once I figure 1 out. And in short, if you look at this diagram here, notice that no matter whether I go left or I go right, I'm always asking 3 questions. No matter what, all of those arrows lead to the first, the second, and the third diamond. So I'm asking 3 questions no matter whether any of those answers are true or false. Well, how might I go about improving this? Well, let me propose that we introduce another keyword to our Python vocabulary, namely elif. And this too is kind of a succinct one. It's a conjunction of else if in English, which allows us to ask a question that takes into account whether or not a previous question had a true or false answer. Well, what do I mean by that? Well, let me go back to my code here, and let me propose that we now improve upon this here by asking ourselves, ultimately, how can we ask fewer questions? And let me go ahead here and propose that instead of asking if, let's make these conditions potentially mutually exclusive. That is to say, don't keep answering questions once we get back a true answer. So I'm going to change my code up here as follows. Instead of asking if, I'm going to say if x less than y, if x greater than y, if x equals y. So I'm going to implicitly, just like in English, take into account that I'm only going to keep asking myself these questions if I haven't yet gotten a true response. Think about the logic here, the English. If x is less than y, on line 4, print out x is less than y. Well, if that's the case, you're done logically. Because if the English is saying if x less than y, else if x greater than y, those are going to be mutually exclusive if the answer to the first question is true. You don't have to keep asking questions to which you already logically know the answer. So let me go ahead now and run this program, and I think the behavior is going to be the same. Python of compare.py, what's x? Let's do 1. What's y? Let's do 2. X is less than y. Now, honestly, I didn't really notice a difference when I ran the program. And honestly, my Mac, my PC, my phone nowadays are so darn fast that these kinds of improvements aren't going to necessarily feel any faster until we're writing bigger, faster programs. But it's laying the foundation for writing better code longer term. Now, what is the improvement I've just made? Well, if previously my diagram looked like this, which was problematic insofar as I was asking 3 questions, no matter what. Even if I already figured out what I want to print on the screen, this new version of the program that has if, elif might look a little something like this instead. Now, it got a little wider. That's just because we drew the arrows to be a bit wider here. But let's focus on just how many questions are getting asked. Let me zoom in at the top as before, and let me propose that we note that the start oval is at the very top, and it's asking us to ask one question first. X less than y. Is 1 less than 2? But notice here, let me zoom out. If 1 is indeed less than 2, we follow this longer arrow down marked true. We print out, quote unquote, x is less than y, but then we immediately follow this next arrow down to the icon that says stop. So that's what's implied by doing if, elif. If we get back a true answer right away to that first if, we're going to print out x is less than y and then stop. We're logically at the end of the program. So this picture is just representing graphically what the code is actually doing. But suppose I typed in something else. Suppose that my code actually ran and I typed in 2 for x and 1 for y. That is to say, the answer to the first question is now false, but the answer to the second question is now true, because of course 2 is greater than 1. Well, let's go back to the diagram. Same as before. We start at the very top where it says start. The very first question up here now, x less than y, is an answer of false, because no, 2 is not less than 1. So we follow this arrow to the next question, this diamond. Is x greater than y? Well, yes, 2 is greater than 1. So now we follow this left arrow, which is true. We print out, quote unquote, x is greater than y, and then stop. So what's the improvement? Well, in the first case, we got lucky and we only had to ask one question, and boom, we're done. This time, we had to ask 2 questions, but then boom, we're done. Only if x happens to equal y do we actually find ourselves logically getting all the way down to this final elif in my code. And pictorially, only if x is equal to y do we find ourselves going all the way down to the third diamond, the third question, asking is it equal to y or not. Now, hopefully the answer at that point is not false. We've included a false arrow just so that the program itself is well defined. But logically, we shouldn't actually be getting there anyway, because it's got to be less than or greater than or equal to in this case. Well, let me pause here to see if there's any questions now, either on the code version thereof here or on this diagramming of that very same logic. Questions here on this control flow?
Aren't we supposed to put an else at the end?
A good question. And yes, so that's going to be my third and final approach. And if you don't mind, let's pivot there right away. Identifying a third keyword that indeed exists in Python that allows us to be even better at expressing this logic, to design this program even better, and that's going to solve a particular problem. So if I take us back to our code here, notice that what I've highlighted earlier, elif x equals y, it's not wrong to ask that question. In fact, if you're trying to be especially thorough, it makes perfect sense to check if x is less than y, greater than y, or equal to y. But why don't I need to ask this third and final question?
We don't need to ask if x is equal to y anymore, because logically, if the 2 conditionals evaluate to false, there is only one conditional that will evaluate to true, and that is x is equal to y.
Exactly. If we're all pretty comfortable with math and comparisons here, of course, x is either going to be less than y, greater than y, or equal to y. But once you rule out the first 2 scenarios, logically, it's got to be the case that x must equal y if it wasn't the case that it's less than or greater than. So Hope proposed that we use this other keyword, else. And how do we use this? Well, exactly as we might in English. Let me go back to my code here. And instead of bothering to ask the third and final question, let's not ask a question at all. Let's just have this catch-all, so to speak, a final line of code that says else, just assume that x is equal to y, therefore printing it as well. So what's the upside of that? My code is still going to work exactly the same. And again, my computer's so darn fast, I don't even notice that it's working even faster than it was before. But we would notice these kinds of things if we were doing a lot more work, a lot bigger programs here. But let me run Python of compare.py. Let's do, for instance, 1 and 2. Still works for that. Let's do 2 and 1. Still works for that. Let's do 1 and 1. And it indeed now works for that. But in these cases now, let's consider the path we just went down. Previously, our diagram, when we had if, elif in place, looked a little something like this. And notice that, again, we might have asked one question or two, or worst case, 3 whole questions. But we can do better than that. Using else as Hope proposed, we can whittle this diagram now down to this. And even though it looks like the diagram's getting bigger, notice that it's having fewer building blocks inside of it. There's fewer arrows and there's fewer nodes in this picture. Let's start at the top now. Start leads us to the first question still. X less than y. If the answer is true, great. We can say as much, x is less than y, and we can stop. If it's not true, if it's false, we can ask the next question. X is greater than y, true or false? If it is, great. We can print x is greater than y and stop. Else, if it's not the case that x is greater than y, the answer is false, we can just immediately, logically say x is equal to y. We don't have to add the third question at all. We can just immediately conclude there. So what's the implication here? You can see with these pictures a relative decrease in the complexity of a program. The first one was very long and stringy with lots and lots of questions, unnecessarily ultimately. The next one got a little shorter, and this one's even shorter still. And again, the fewer lines of code you have, the less likely you are, arguably, to make any mistakes, the easier it is for other people to read. And so generally, this readability, this simplification, is indeed a good thing. Well, let's go ahead and add another piece of capability into Python, and that's this one here. Just like in English, where you can ask this question or this other question, you can say the same thing in Python using literally this word or. So let me go back to my Python code here. And let's propose how we might ask a couple of questions at once this time. Perhaps this time considering how we might ask not whether or not it's greater than or equal to and caring about the precise answer. Let's take a coarser approach here, and let's just try to determine, is x equal to y or not? Well, let me go ahead and delete some of this code and change the question we're asking. Let me do this. Well, if I care about whether it's equal or not, let's check the possible scenarios. If x is less than y or x is greater than y, let's go ahead and print out x is not equal to y. Now, why is that? No pun intended. If x is less than y, well, it's obviously not equal. If x is greater than y, it's obviously not equal. So we can conclude x is not equal to y. So if we instead want to make sure that it is equal to, we can just use Hope's else, using print, quote unquote, x is equal to y. And again, why is this? Well, if x is less than y or x is greater than y, they're obviously not equal. Otherwise, logically, they must be equal in fact. So let's run this. Let's go ahead and run Python of compare.py. What's x? 1. What's y? 2. OK, x is not equal to y. Let's do it again. But 2 for x, 1 for y. X is not equal to y. And one third time, how about x is 1 and y is 1? X is now equal to y. Now, if we want to compare that visually too, let me propose that the picture looks a little something like this. And again, this is the exact same thing logically, but it's a pictorial representation thereof. What's the first question? Well, if x is less than y, well, then we follow the true arrow and we say, quote unquote, x is not equal to y, and then we stop. But what if x is not less than y? What if it's greater than y? What if it's 2 and 1 respectively? Then the answer to x less than y's first question is false. So we go here. We ask the second question because of the or, and that asks, is x greater than y? If so, notice this. We can kind of reuse some of the same parts of this picture and just say x is not equal to y. We don't need to add arrows and add boxes unnecessarily. We can reuse lines of code, parts of the picture just as we have lines of code. And then we stop. Lastly, we have the following. If we know that x is not less than y, we know that x is not greater than y, it must be the case that x equals y. We don't need to ask a third question, another diamond. We can just immediately print as much and then say stop as well. Well, what could I do here? I bet I could improve this code slightly. And if we really want to be nitpicky, I would argue that this is now really just a minor refinement, but it's a good habit to get into thinking about, could my code be better? Could my code be simpler? Could I improve this code further? It's subtle, but could I improve the design? Could I ask fewer questions? Could I tighten it up, so to speak? What do folks think?
You can ask if x is just equal to y. Then it will print x is equal to y, else x is not equal to y.
Perfect. Recall one of the other symbols we saw in the available list earlier. We can check not just less than or greater than or equal to. We can literally ask the question, is it not equal to? Why are we wasting time asking if it's less than or if it's greater than? Well, if all you care about is it not equal, I think we can do exactly that. Let's just ask the one simple question we do care about. And so let me go back up here and let me just say, not both of these questions. Let's get rid of the or. Let's just say if x is not equal to y, then go ahead and print x is not equal to y. And that, too, I think is going to work exactly the same. But the picture now looks a little bit different. Notice that this was our flow chart earlier that represented that same logic. And there's a bit of complexity. You got to go left, you got to go right based on the answer to these couple of questions. If we now take into account what this version of the program looks like, it's even simpler, perhaps the simplest one we've seen yet. When we start off the program, we ask just one and only one question. Is x not equal to y? And if so, true, we go ahead and print out x not equal to y. If the answer is false, then of course it must be equal to y, so we say that instead. And if we really want, we could invert this. If I go back here to y, so we say that instead. And if we really want, we could invert this. If I go back here to my code, and if for whatever reason you just prefer to think in terms of equal or not equal, as opposed to not equal or equal, it's really up to you. We could change this to be equals equals, but I'm going to have to change my print statements to be in the opposite order. So let me go ahead now and reverse these two here and move the second one first and the first one second. So now when I execute this code, I'm asking still just one question. So it's still just as good, just as succinct. But now the diagram, instead of looking like this, is going to change the not equal to equal equal. And we just need to make sure that we print out the right thing accordingly. And again, here too, just as the code is getting a little more compact with fewer and fewer characters, so are these diagrams, these flowcharts, capturing the relative simplification of each of those programs too. All right, let me go ahead and pause here to see if there's any questions now on any of these versions of code.